Hello everyone, good morning. Good afternoon. So our next topic now, this is actually our last topic also, so about transformers. Okay, so we're just going to identify the different types of transformers and how they are used in the power system. Okay, so we are already familiar with transformer, which has step up or either step up or step down and with two coils, so the primary and secondary coils. So if we have here, for example, by the way, are you hearing me right now?
Yes, sir.
Okay, so if you consider step up transformer, so the voltage in the secondary is higher than the primary. So but the current will be lower. So that's something that is obvious for transformers, and the power for both windings will be the same. Okay, or the QVA. Then also special now for the terminal marking. So we have take note that for always the whichever is the higher side, so it will always be labeled as H. Okay, then for the low voltage side, so it will be labeled as X. Okay, it could be X1, X2, X3. It depends on the number of terminals. And here also it H1, H2, H3. Again, depends on the number of terminals. Then, yeah, so these are the different markings that we have to take note when looking at transformers. Okay, then usually, so I think there's a picture here. So if, for example, this transformer we're considering, so it's obvious that these terminals, so Hanisha, and this terminal are the terminals for the high voltage side. Okay, so usually distribution poles are step-down transformers, and these terminals are used for the low voltage side. Then also we can actually see the from by just looking at these terminals, we can also already identify what kind of connection this transformer has. Okay, so whether it's additive or subtractive. So if they aligned, so let's say for example this is H1. Okay, because usually in the left side they have the start, so this H and this H1 and this is H2. And if this is constant, no, X1, X2, and X3, for example, so we could say that since H1 and X1 are located in the same side, so this transformer is considered to be a subtractive transformer. So which is the most typical transformer connection. Okay, so transformer can be constructed also using dry type now. So meaning there's no insulation inside. So therefore, we call it dry type transformer. It could be that it is epoxy insulated, or it could also be ventilated like this. Okay, so just the open wiring of the windings, but we have here different vents now for flow of water, no, flow of air, so that it serves as its cooling. Because as you can see, so since wala man siya oil, it doesn't have they call it cooling system. Okay, so dry type, the standard ng mga oil immersed. So it can be single phase or three phase. So it doesn't matter. Then also transformer, not just although usually when you hear about transformer, so we consider about the power transformers or the distribution transformer, but it can also be used to transformer to provide power for our control systems or our motor controls or relays. Okay, so just like these small transformers. Okay, then we also have this liquid field transformer or the oil immersed transformers. Okay, so with this one, since na naman siya oil, no? So if you look at the construction, it's much more complicated, but it can handle more power than the dry type transformer. Yeah. Okay, so then we have this type of transformer, no? So an auto transformer. So this is just single winding transformer in which this connection here. So uh, it, it has a contact to the winding that if if this is rotated, so it will have a different tappings. So for example here, so this glides through this winding. So the ratio of the primary and secondary will change so that we can, by that we can control the output voltage that we really want. Okay, so this is actually the typical transformer used for AVRs now, so or automatic voltage regulator, because as again, it can control the voltage. And let's say that this is controlled by, so this rotation is controlled by servo, and we have here the detector that detects the output voltage. So if it is less than the actual voltage, so we connect this we change the tapping so that we have here increase in voltage. Okay, so this is a buck configuration, while this is a boost configuration. So we'll see for the buck configuration now, the load side has a will have a higher voltage, but supposedly if we have a boost now, so dapat the voltage is higher and back should be lower. So this is correct because of the direction. So going that way, line voltage, 0. So probably something to do with mga what do you call it? Terminologies lang. But usually especially for electronic circuit, so buck is used for stepping down the voltage and boost is for stepping up the voltage. Okay, then electrical distribution and control applications. So these are the different types of transformers you can find in an electrical in a distribution system. So you could have these distribution poles or pole mounted, and we have here the pod mounted, platform, and voltage. Okay, then we also have here different instrument transformers. So for example, here we have this current transformer, then we have here these voltage transformers or potential transformers, and we have here these an example just on isolation transformer, so with ratio of 1:1. Then yeah, so in the code, so it's required that all transformers are to be guarded, okay, in any means, no. So for example here, so since it is mounted on top, near on top of the pole. So therefore, there's a clearance from the ground. So therefore, it's considered to be grounded. I mean, guarded. Okay, or if it's not possible because you don't have a pole to install the transformer, so like this, so you just have here a pad mounted in a transformer. So you just need a fencing so that you can isolate the system from the mga uh, external mga extrusions. Okay, then there's also a requirement for the minimum height of your fence. Okay, so we have here 1 foot for the barbed wire and 6 foot for the fence. So that's why if you look at mga transformers, especially mga power transformers, so either they are installed high above, or if they are installed on the ground, so there should be a fence that protects this transformer. Okay, so one reason for that is aside from basin niya og mawala, but also to protect mga those curious nga mga uh, it could be animals or even personal that could enter this facility. Then yeah, so also it's required that if it is if it is dry type transformer, then there should be an enclosure. Okay, so that's one way of guarding your transformer from mga external agents. It could be combustible materials or fluids. Okay, then also there should be a warning, no? So especially kani siyang uh, mga transformer using enclosures, okay, because it could be that there is already a leakage voltage or current through this enclosure. Okay, then even if this one wala ni siya leakage through the fence, so we still need to provide warning sign here. So especially kung ito siya high voltage keep out. So we should that because that is required by the code also. Okay, then all transformers are required to be ventilated. Then aside from that, so all transformers also must provide, or all manufacturers of transformer must provide the specification of that transformer on the nameplate of the transformer. So and the nameplate should contain this information. Okay, so name of the manufacturer, rated kVA, frequency, primary and secondary voltage, impedance. So just 425 kVA and larger, then clearances and insulating liquids and temperature class. Okay, then if transformers are um, actually it is allowed to be hung, so as long as there is enough ventilation. Okay, because uh, yeah, so usually diha magud mo karon sa ibabaw saka magud ang tanan nga kainit. So dapat we should make sure that this is properly ventilated when we install it on a higher elevation, especially indoors. Okay, then for less than 112 and 1/2 kVA, so there is a minimum clearance between the combustible material and the transformer. So such as this one, so 12 inches or 1 foot. Okay, so again, this is the same now. So you need to have, okay, so you need to have here 12 for equivalent for standard transformer. But if you have here like this transformer that is totally enclosed, so with class 155 insulation, so it is not required now to have this minimum clearance. It could be less than 12 inches or 1 foot. Okay, then for transformer larger than 112.5 kVA, so with this class now insulation, so permitted to be installed indoors if so it's separated from combustible materials. So like this. So we have these minimum clearances. So from the sides we have 6 and the top we have 12. So this is just for sizes greater than 112.5. Then larger transformer than 112.5 installed outdoors shall be located. So you see no almost the same lang yapon ang ilang mga clearances. So 12 inches. So just take note of these mga numbers. So for transformers, so 12 inches always yung mga clearance from combustible material. Then we also have here another type of transformer. So LFLI, or the less flammable liquid insulated transformers. So for indoors, so it should be not permitted to be installed indoors if we follow these conditions. Okay, so yeah, so these are the different conditions. So for example, rated 35,000 volts or less. So which is usually applicable sa mga distribution transformer. Then, or even sa mga industrial ng mga transformer. So no combustible materials stored, then liquid confinement area provided, installation per liquid listing. So basically there are mga so there are mga conditions lang where you can install in this kind of transformers or LFLI that we have to follow. So in general, so I think you can see already know that we should make sure that our transformer has a protection, so or it should be isolated from external agents, and it should have proper ventilation. And if there are possible combustible materials, so there should be a separate, uh, required minimum distance between the transformer and that combustible material. Unless your transformer is fully insulated, okay, or it has some kind of an enclosure that is that makes sure nga walay fire nga metal. Okay, so just like for this example here. Okay, so it's allowed to have even if this is combustible, not because this is wood, so it's still allowed to install without kind of specific clearance if this transformer is completely enclosed. Okay, so the openings are only used uh, for vents or ventilations. Okay, so non-flammable liquid fluid insulated. So there is this another another condition that it can be installed. Then yeah, so we have here a Ascarel insulated transformer. So there is these mga requirements in order to have to follow. Okay, so if this is an Ascarel, so rated over 35,000, so it should be installed in transformer volt like this, because actually the transformer Arcadia Ascarel is, I think right now it's already been banned for most application in transformer insulation because this is considered to be um, what do you call it? Carcinogenic. So therefore, with regards to health issues, ilan na siyang gi-avoid. But there are still some mga very special nga mga applications that still uses Ascarel because it has a very good volume or resistance per what do you call that, volume. So gamay lang kayo nga Ascarel, so taas na kayo siya og insulation level. So which is good for transformer operations. Okay, so oil insulated transformer less than 112.5. Okay, so this is now uh, the but you see still even if it has the same different nga insulator, so still we need to have a what do you call that, a container for this transformer. But there are just certain mga mga thickness or requirements nga specific for each of the transformer. So we're not going to discuss this now because uh, anyway, so if you have, let's say, if you are going to design now your transformer panel system, so you can just look back or search it again in your national electrical code or Philippine electrical code on what to follow, no? On what design to follow for this kind of transformer. Okay, but for now, so what we need to know is that mo to siya, in general, transformer needs protection and must be isolated from those possible combustible materials. Okay, so transformer, then volts. Okay, so you see, we have here volts uh, just to stop the fire uh, from scattering to the next buildings. So yeah, so let's have here now some calculation. So if we have a this kind of transformer, so sizing primary over current protective device, so this is non-supervised. So meaning non-supervised, dili siya nga naka-stick to, no, so that only those trained and personnel can enter this facility. So therefore, being mga, ano, mga tag-iya, pwede siya makasulod. So this is for the primary. So if this is a step down transformer, so therefore we expect that the current here will be smaller. Okay, so 50 kVA. So transformer with 6% impedance and 4160 primary. 4160 primary. So what is this connection? Yeah, so we have here, so just the standard formula no, for three phase, because this is a three phase. So I is equal to kVA divided by the voltage times square root of 3. Okay, so we have here 50. Oh, so 50 for the size for the kVA, then 1000 for the K, for 160 for the voltage, and 1173 for the square root of 3. Okay, so that we have here the current per phase is, the line current, so that the current per phase is equal to 6.94. Okay, so that's the current that may flow through this fuse. Okay, then we use this because we are going to use a fuse. Okay, then we go to 450.3 A. So 450.3 A. So over current protection. So for A, so transformers over 1000 volts nominal. Okay, over current protection shall be provided in accordance with table 450.3A. So this is table 450.3A. So yeah, so we look at the so here in this three phase we have impedance of 6%, then voltage for 160. Okay, so meaning it's over 1000. Okay, so we use this, and so 6%. So what's it exactly? So with impedance, yes, it's not exactly 6%. So not more than 6%, not more than 6%. So this is for unsupervised, non-supervised. Okay, so any location. So man siya. So we use, so for the fuse, so luckily no, for the fuse, it is the same for not more than and more than. Because we don't know no, asa siya belong, because it is exactly 6%. So luckily since they are the same for the fuse rating, so we use that directly. That is 300% for fuse, and 6.94 times 3%. So we have here 20.82, and we use the standard rating next higher. So next higher is a 20.82 is 25 amperes. Okay, so we use this size for our OCPD. Okay, then for supervised transformer, so over 600 volts shall be provided with OCPD not exceeding 250 for fuses and 300 for circuit breakers. So look at here. So this is for supervised, and for uh, so this is for more than and not more than, so 250 and 300%. Circuit breaker. So for supervised, then this is not required 250. Yeah, so this is a fuse, and the rating for the circuit breaker is less than over 1000. So this is less than 1000. Over 1000. So this is so, but we have here what is the primary, what is the maximum size primary. So therefore we have to calculate for the primary over 600. So where is over 600? So but there is only over 1000, more than 6 and not more than 10. 300. So note 5. This one's different note. Circuit breaker or fuse. So in here, so this is 250% and this is 250%. So both for circuit breaker and fuse. So I don't know where you get from. Kani siya nga. Yeah, so probably no. So something has changed already because this National Electrical Code is based on 2011. Okay, so 2011 is yeah, while kani siya nga table is 2017. Okay, so yeah, so we use this 250 or 250. Okay, so for what is this one? Using an adjustable trip permitted to protect the supervised transformer. So basically the same like you use 300, but in here, so if I cannot use this over 1000 because the voltage here is just over 600. So therefore it belongs to this uh, so primary. So but this is primary of CPT. Okay, so probably something has changed already now. So this one 600 volt, and since this is for the primary OCPD, so we have to look at these columns. Okay, so we have here circuit breaker and fuses. So and because this is not more than 6% and this is not more than 6% and more than 6% and not more than 10%. So therefore wala ane. So therefore we belong here sa any. Okay, so in here, so we have, if we are using circuit breaker, so just say that is, this is for over 600 sat because there's no other option. So therefore we use 300% for circuit breaker and 250 for fuse rating. Okay, then since this is an adjustable trip circuit breaker, so therefore we have to look at this column. So for circuit breaker, so 300%. Okay, so that's why we have here 6.01 times 300%. Okay, then yeah, so we still, according to note 1 here, so we have to use the higher rating. Okay, so we use have here 18, so we use 20 ampere. Then this is another supervised transformer. So what's the difference between these two? So 600 supervised over 600. Okay, so we have here primary and secondary calculations. So that's the only difference. Okay, so what size primary and secondary OCPDs using circuit breakers are needed to protect the supervised transformer? So again, that's here in this table, 450.3 A and So this is over 600. So let's just say this is over 1,000 now because there's no other option. So we only have here one over 1,000. And for what is this transformer? So we have here 25 kVA, then impedance 3%. So therefore, 24. Yes, actually, no. Sabi ko sa akong nabasa din na. So although this is over 600, but yeah, so kani siya ang sayop lang because probably right now, so it's already over 1,000 transformers. So wala na i-range over 600. But we still have to use this column here because the voltage actually of the transformer is 2,400 volts. Okay, so therefore it exceeds 1,000. So just like this. And in this case, so the voltage in the primary is 4,160 and the voltage in the secondary is 2,4. So therefore, both of them exceeds 1,000. So we can use the same table. Okay, then we solve the line current. So 25. So 25, then the voltage 4,160, and here is 24,000, 2,400. So we have here 3.47 and 6.01. Okay, then we look at the multipliers now. Because the impedance here is 3%, so 3%, not more than 6%. So we have it here. So not more than 6%. So therefore, we use this uh, multiplier. So for since we're going to use circuit breaker, so we use this 600%. Okay, so yeah, so we have here 600%, and so we have 3.47 times 600, so it's 20.82. And the next standard is, oh, so it's not the next standard now. So we have to look at, so column B, next higher. So the primary, note 5, mission 450.3. This is next lower, and this one next higher. Supervised, then this is also supervised. So what's the difference? A, B, C over 1,000 less than 1,000, and so we have here less than 1,000. So it's a different settings. higher rating or setting that uh, exceed does not exceed the following shall be permitted. So A, next higher standard rating or setting for fuses and circuit breakers, 1000 volts or below. Next higher commercially available rating for fuses and circuit breakers above 1000 for secondary commercial. 6 shall not exceed where multiple overcurrent devices are utilized. The total of all device ratings shall not exceed the allowed watt value. Okay. The total of the device. Okay, so a supervised location is location where conditions or maintenance and supervision ensure that only qualified persons monitor the service of the transformer installation. So actually I cannot see no. So why this is next lower because it's not stated in the code. So why we have to use next lower standard. Okay, so all that is being stated here. Okay, so actually this is the maximum rating now. Let's look at here. 18. Okay, so 1820. Okay, so when we use this table, actually, so maximum muna siyang rating, so therefore, it should not be exceeded. Okay, but the problem, what I'm saying here is that there's no way we can tell when to implement this next higher because it's just said here nga, when it does not correspond to standard rating, so we use next higher. Okay, so I see here, so this is the maximum rating. So therefore, we should not exceed these values, whatever is calculated here. So we should not have a rating that exceeds that value. So that, for example, if we have here, um, in this case, so if we calculated 20.82, so if we use the next higher, so that is 25, so therefore it already exceeds this value. Okay, so same goes for this one. Okay, but my problem is how do we know when to apply the next higher? Okay, because basically this is just the same number, so 18.03, and is also 18.03. Okay, but they have different settings. Secondary, primary, and there's no node nowhere. So we have here node 1. So node 1 next lower. So let's see. So where the required fuse rating or circuit breaker setting does not correspond to a standard rating or setting, higher rating or setting that does not exceed the following shall be permitted. The next higher rating or fuses, breaker, and below, or the next higher rating. So if we just read this now, so supposedly this should be 25, and this should be 20. Okay, because it refers to note 1 and there's actually no mention of next lower there. So probably, again, this is from I'm using a reference from 2011. So probably if we refer this to 2011 National Electrical Code, so we also get the same now. So since this is revised every 3 years, so there's already two iterations now from this one. So we already have 2014, then this one 2017. So yeah, so maybe diha sila nagkalahi. So why we have here different notes. Okay, so let us just follow this one. So since this is the latest, so actually not the latest now because we already have now 2020. So but this is later than this one. So we use these nodes here that we need to use next higher as long as we don't exceed the next standard rating. So when we say we don't exceed, so for example, if we let's say since this does not correspond no, to a standard rating, so we can use 25. Okay, and that 25 does not exceed the values provided by this 240.6a. Okay, so because 25 is equal to 25, so wala siya exceed. Okay, so let's just use that. So again, this is a little confusing because wala siya, there's no way of knowing when to use next lower or next higher according to these calculations alone. Okay, but if we use this, so dapat next higher kita. Okay, then you also see no that if we have percent impedance of the transformer, so we have higher multipliers. Diba? So you look here, so not more than 6%. So probably we have 3, 4, 5. So mas dako siya og multiplier because we expect that at higher at lower impedance, transformer impedance, so the inrush current will be higher. Okay, so that's what we are trying to protect here. uh, we have to make sure that the transformer will not trip off, or the OCPD of this transformer will not trip off during the starting or the inrush current. Okay, so agree lang tayo, no? When we calculate this, we go next higher. Okay ba ta?
Yes, sir.
Okay, so this is next higher, so we don't go next lower. So because wala siya diri sa notes that mentions next lower. Then transformer less than 600 volts shall be provided with primary OCPDs not more than 125%. So probably again this is 1000 in this version of PDF. So we have to use this table 450.3b. So maximum rating of setting over current protection transformers less than 1000 volts or less. Okay, then yeah, so if you look at the given specifications of the transformer, so we have here 15, then 208. Okay, then we're looking for primary OCPD. Okay, so primary. So actually, we still have to calculate the currents. Okay, so we have here, if it's 9, so we base on these multipliers. And if this is less than 9, so we base on these multipliers. Okay, so let's calculate for the current. So according to this calculation, since this is three-phase, we use this same formula. So the current is 52.09. Okay, then no, not 52, but 41.67. So that is greater than 9 amperes. So therefore, we have to use this one. So 125%. So for the primary protection. Okay, so 125% times 41.67. So we have here 52.09. And again, it does not correspond to standard rating. So we use next higher. So that is 60 amperes. Okay, so you see, no, dako kayo difference sa current, but since mamana siya ang dimension sa code, so we have to follow it. Okay, because there's no 55 no in 240.6. So after 50, so by 10 nasa dang lahang differences 50, 60, 70, 90, 100, 110, 125. Okay, then yeah, so we use this 60 amperes. Then how about here? So this transformer is 6 kVA, then this is the voltage. Then if we calculate for the current, this is still three phase. So the current is 7.22. So if we base that here, 7.22, that is less than 9 amperes. Okay, but that is not less than 2 amperes, so it belongs here. So we use this 167%. So since we are still going to solve for the primary protection alone. Yeah, so only the primary protection. So we have here 167, so by 7.22, so we have 12.06. So how about for this one now? So this is next lower. So let's look at the nodes now that we can apply here. So why we need to use lower. So we're 125% response and rating. So for just about, so we have to use higher rating. So which is correct based on our first value. Then for secondary, okay, okay. So I now understand now. I now understand why we have to use next lower, because again the default here is that this should be the maximum, but if na siya note, so we have to what is siya, we can apply these notes here, but since this one there's no note here, so 167, so therefore we have to follow this maximum rating. Okay, so since that is the maximum rating and there's no note to follow, so we by default we have to go next lower. Okay, so sorry now. So I just understood why, what's the purpose of these notes. Okay, so again, these notes are only applicable for kung asan mo nakita ang notes nga percentage. So in this case, so for 167, 300, so there are no notes. So therefore, we by default we use this automatic na maximum rating. So 167. So according to the multiplication, so the value here is 7.22. So yeah, so 7.22 times 167, so that is 12. Okay, then yeah, so the next higher is possibly 15, but since according to the table, wala man siya notes to use next higher, so we go by default next lower. So that's why we have here 10. So if we apply the same concept here, so kato siyang na-confuse ko ganiha. So wala na ako na notice nga this 600 and 300 probably wala ni sila yung mga notes. So yeah, so this one, 600 and 300. So wala gyud siya notes, no? So therefore, we cannot apply this next higher nga notes here. So by default, again, we use the next lower. So sorry, no? So this one is the correct actually. So we go next lower if there are no notes to apply, and next higher if notes applies. Then how about here? So this is for 0.25 kVA, then 240. So if we calculate for the current, so we have 1.04, so very small current. So it belongs to, so this one. So less than 2 amperes. And we are to install only primary protection. So we use this primary only. So 300%. So 300%, then so again there's no note here, no. So therefore we go next lower. Okay, so 1.04 times 300%, 0.12, 10. So if we look at the standards, so I'm not going to go there now because mawala na sa siya na page. Okay, so we have here standard 3. So we use 3. So by the way, ako na lang to, no, because 3 is not common. So 240.6. So you see here, the most common are starting from 15 to 6,000. But you can also see some other uncommon sizes of fuses here. So we have 1, 3, 6, 10, and 610. So based on our calculation, so we have here current of 3.125, and since there's no node to next use next higher, so we use 3. Okay, so transformers less than 600 volts are permitted to be installed without individual primary OCPD with the circuit. OCPD provides the protection. Okay, so because this is not necessary now since di naman siya ay OCPD dire. Transformers under 600 volt may be protected by primary. So again, in this newer version of the electrical code, so this is under 1000 now, may be protected by primary and secondary. Okay, so we have here two protections, both primary and secondary. So therefore, and since this is again less than 600 or less than 1000, so therefore we use the same table to 450. Okay, so 450.3b. So we have here the transformer is three phase 480 45 kVA. Okay, so yeah, so we have here this based on this calculation. So we have current of 54.19. Okay, so that is over 9 amperes. So let's just say here. So over 9 amperes, and since we have both protections now, primary and secondary, so we use this rating, multiplier. So 50%. So that we have here 54 times 250, so we have 135. And if you look at again, so we have here this node. So we go to this node, a transformer equipped with uh, coordinated thermal protection by manufacturer and arranged to interrupt the primary current shall be permitted to have overcurrent protection rated or set at a current value that is not more than 6 times the current of the transformer, for transformer having not more than 6% impedance, and 4 times the rated current for transformer having 6%, not more than having more than 6%, but not more than 10%. Okay, so but if you look at this ko, so wala ta ato nga mga informations, ato nga notes. Okay, so but pila man siya. So that's why in our case, so nabatay protection na rin. Okay, so wala sa tayo thermal gag-mention, so therefore this node 3 does not apply. Okay, so it's only for thermal overload protection and this impedance nga percentage. So again, wala tayo today, so it can apply. So we go next lower. Okay, then how about here? So for the secondary, so we have here this uh, probably the same plan siya, no? So 480, probably this is 480, 208. So 480 divided by square root of 3. So 2777. Primary, secondary, 120 square root of 3, 208. So sakto. Okay, so the voltage is 208 for the secondary, and yes, we have this current 125, then How about the ano? So 125 amperes. So that's for the secondary. Then for the secondary, so we have to use this 125%. Okay, so that's why we have here 125. So 125, 125 is 156.25. Then, so let's see if naman siya note. So we have here note 1. Okay, so in note 1, so we can go next higher. Okay, so next higher for this 156 is, yeah, so as I mentioned, no? So after uh, value now is after 150, so mahimo na siya, 125, 150, 175, 200. So we have here standard 175, so we use this 175 amperes. So I think this is the last example. Okay, so what size? What size primary and secondary? So we still have both kind of protection. Using fuses are needed to protect the transformer. So we have these transformers, and so the sizes are so 2, and they are the same now, 2 kVA, that is also 2 kVA. So the same transformer. So therefore, so it seems like double lang siya. So we just multiply it by 2, so whatever is the value that we calculate from this one. Okay, to obtain the total current here. Okay, so kVA, then yeah, so that's why it became 4 here, no? So 2 plus 2, so that's why that I 4. Then the voltage in the primary is the same, so 480. So 480, yes, we have here 4.82. Then if you look at the table, so 482, 4.82, so that is below, less than 9 amperes, so we use this 250%. Okay, so we have here 250%. Then let's see if naman siya note. So at I note at note 3. So again, this is the same the same note earlier, that it has to be based on the overload protection and the percent impedance. But since wala mataane information, so we just go next lower. Okay, so 12, so we use 10 ampere fuse. And for the secondary, so we expect that they have the same secondary protection, because we have here the same transformers. So we have here 2 times 1000 over 208 the voltage line to line. So we have, yeah, so 5.55. Okay, so 5.55 less than 9. Okay, so we're now here in the secondary. So less than 9, so this one, and 167%. Okay, so 167, then multiply 5.55, that's 9.228. And we have here, so there's no note, so we go next lower. So for the next lower, so 9, again, it's not a common, not a common size. So have to go back here. So we have 136, so lower by 9 is 6, so we use 6 amperes. Okay, so that's why we have here 6 amperes. Okay, so katulad siya, no? So ito ko na sa iyo, sa wala na ako nabantayan nga natay mga nodes that are only applicable for specific na mga multipliers. So we have to consider that if there's no node, so we have to uh, use the default, no? That is, the calculated values are the maximum values, therefore it should not be exceeded. Okay, so questions so far. You have questions?
And so far, sir.
Okay, so you may now leave if you don't have questions.
Maraming salamat, sir.
Sir.
Thank you, sir.
Thank you,
Thank you,
sir.
sir.
Thank you, sir.